So in this video, we're going to cover a little bit about more about radiation and the implications of our daily lives. So the units of radiation, I got a couple different ones. The first one is a rad, R-A-D, which is basically just a different measure of the absorption of radiation into the amount of body flesh or tissue. So rad's absorption of 0.01 joules of energy per every kilogram of body tissue. Now a rem is denoted by the letter N, which is the number of rads. So they're directly related, but rads is probably more frequently used to adjust for relative effectiveness of the radiation and causing damage to humans. So rads is just the measurement. REMS is more of a measure of the danger, the effectiveness of that radiation to actually harm you. So generally, we encounter a background radiation here on Earth of around 0.13 REMS per year. A chest x-ray gives us 0.05 to 0.2 REMS when we go and get one of those. Anywhere from 0 to 25 REMS causes no detectable damage. So all of these things that we encounter on a day-to-day basis do not get close to harming us, but it's when we're prolonged for long periods of time or if we're constantly encountering large amounts. So ionizing radiation knocks electrons off of atoms that bombard a substance to produce ions. So things like alpha, beta, and gamma, and X-rays. So we're going to actually look back at this electromagnetic spectrum, which we looked at in Unit 3 a long, long time ago. Cell phones do not use ionizing radiation, so a lot of people think that radioactivity is dangerous, the waves are harmful, but that's not true at all. Headaches, sure, if you're staring at a white screen, you'll get headaches. Your eyes will get fatigued. You may have strain on your eyes and retinas. Skin sensitivity, no, not that we know of. It falls into a safe range. We use microwaves every day, and the radiation that's put out by cell phones is about the same as microwaves or radios, and people have been listening to radio for years. How can we detect radiation? We use a couple of things. Number one, Geiger counters are common. Gas-filled metal tubes that help detect radiation. They often have a little sensor on there. Primarily detects beta. Scintillation counters, specially coated screen to detect radiation, can detect all types of radiation. And then film badges are kind of like a piece of paper, and they detect beta and gamma. They may change a little bit of color in the presence of radiation. So people who work in these plants will use one or all of these ways to help detect whether or not there's radiation around. We can use radioisotopes in research and medicine. We have radioactive tracers, where we basically inject into our bodies some sort of radioactive atom, like iodine-131, which helps us check for thyroid problems. We can trace the radioactive atom throughout the body and see where it's going, see where our body has problems. Radioactive barium is also used for digestive system problems. You'll drink the barium, and you can actually see where it's traveling into your digestive tract and if there's any issues there. Cobalt-60, cesium-137 are used as radiation sources for cancer treatment.